So I was watching LGR's Tech Tales earlier today. I like watching LGR videos and Adrian's Digital Basement and the 8-Bit Guy. I like watching a lot of these guys' videos. There's some great videos there. Anyway, I was watching an LGR video earlier today on the Y2K problem. And that got me thinking about the Y2K and my thoughts at the time and what happened. And I actually posted some comments on under Adrian's video, under LGR's video here, under Clint's video. And I talk about the problem with con artists trying to sell their DVDs and books and stirring up hysteria, and how they always go hide under their rock again when it's all over and nothing happens. And and I also talk about the problems with COBOL. And and I've actually got a bunch of old compilers. Of course I have. I've got 4 decades of programming experience. So I've got compilers going back to the early 80s and maybe even earlier. Yeah, actually I have got earlier ones because I've got the Apple II ones going back earlier. And I should do some videos of those on whether they're Y2K compliant or not, or what their Y2K features are. No one will watch it. It'll just be another video no one watches. But anyway, there's my comments there under LGR's video if you're interested. But anyway, LGR had some interesting comments that reminded me there's other date problems, and of course there are. And so let's just stop and hear what LGR had to say about this.
Let's hope the media, the industry, and the public alike have learned their lessons then, because calendar-based computer problems continue to crop up, and there's no telling what kind of technological silliness lies over the horizon.
Yes, exactly right, LGR. And he's quite right, of course. There's a whole lot of bugs that have been, and there's the Y2K. There's been a whole bunch of other ones. Probably the next biggest one coming up's the year 2038, when there's going to be a lot of issues with Unix time. And of course, there's still ones well beyond that, the 10K problem. If programmers are hard-coding their programs to handle dates with 4-digit years, what happens when they're 5-digit years? So, yes. A big mistake with programmers is that they assume their code won't be running in 10 or 20 or 30 years. And it's frequently turning out more and more that it is still running in 10, 20 or 30 years. So all programmers should be thinking about how to make their programs future-proof and bug-proof and as robust as possible. So limiting your dates is just one aspect of that. It's all comes down to experience. There's so many ways to trip up and so many ways to fail. Dates and time problems are just one small aspect of the big tapestry of being a good programmer. Anyway, on to the year 238 problem. So, and this is the same animation that Clint used in his video. So that's where he got it. It's just an animated GIF. And the problem is that Unix dates, or at the moment, some Unix dates anyway, are 32-bit signed integers. And what that means is there's a maximum value they can store. And it's number of seconds since 1st of January 1970. And when that reaches the maximum value it can hold, it wraps around and becomes a negative number, and then the date becomes 1901. So you could be in 2038, and then all of a sudden your date becomes 1901. So that's if the problem isn't fixed, of course. And so no doubt there'll be hysteria coming up about that, and the other problems as well. You can check the Wikipedia page, the other problems coming up. There's going to be hysteria about all of these, and people will be trying to sell their books and DVDs and sell their magazines and newspapers by whipping up hysteria, as they always do. So that's basically it. So I saw this animation in LGR's video, and there it is on the Wikipedia page, just an animated GIF. And it got me thinking, that'd be fun to write a little program to do that, and maybe teach other people how to do it as well. So that's why I'm doing a video today, to show you how to do that. So we're going to make a little Java desktop app that does this same sort of thing, counts down in binary and decimal, we'll probably add octal and hexadecimal in just for fun, and we'll show what happens to the date when the value wraps around to a negative number. Ooh, it's fun. So I'll put a lot of this stuff on under the video. I'll put all the links to LGR's video. And the interesting part that I just showed you happens at 2016. So I'll put a time linked reference in there, so you can just click on the link and it'll take you to the right time in the video. And there's the links for the Wikipedia pages we just looked at. So Unix uses a signed 32-bit integer, and it's the number of seconds since 1st of January 1970. And there's the time formatting bugs that are coming up and been in the past as well. It's not just formatting, it's wrong values. It's not just formatting at all, so it's storage as well. One thing about Java is Java uses 64-bit long integers to represent dates. And that's milliseconds since 1st of January 1970. Unix is the number of seconds, and Java is the number of milliseconds. But Unix uses 32-bit integers, or 32-bit Unix does, and Java uses 64-bit integers, or 64-bit longs. Okay, so Java's actually got no worries at all for another 292 million years. So if any of my code's still running in 292 million years and there's a problem with it, well, just recompile it and Java will have fixed it by then if Java's still around. I don't think computers will be around as we know them at all. They'll be, if humans are still around, it'll be so vastly different. There'll be the only people running code like mine will be people just nostalgic for emulation, emulating old code that was there 292 million years ago, so I doubt it's going to happen. Okay, so let's have a quick look at things. So, because Unix uses 32-bit signed integers, and Java uses longs, unsigned 64-bit long integers, we have to do a little trick to make it so the Java dates act like Unix dates. We can't just get the current date or get the date 5 seconds before the problem happens in 2038. We've got to just we're going to work it out using longs and set the date using that long value, not let the date count up by seconds directly. Okay, so we're going to do a bit of trickery. So I'll just walk you through a bit of code I've written, and so it's a console application, and I'll take you through the date time display. So this method gets called every second. It gets called from the seconds timer. So seconds timer fires off every 1,000 milliseconds, and it calls the date time display method, which is this method here. So every 1,000 milliseconds or every second, this code here will run. So I'm getting the current date, and I'm setting it to the value represented by this seconds value times 1,000. Don't forget Java uses the number of milliseconds since the 1st of January 1970, so we're going to multiply by 1,000 to get milliseconds. Then I'm formatting. I've got a date format here, so it's the day of the week, the day, month and year, and the hours, minutes, seconds, AM, PM, so just a standard sort of date format. And so every second I print out the binary value, so I get the seconds value and convert it to binary. So 2 unsigned string, comma 2, that's the radix. So radix of 2 means binary. It's just started raining outside, which is nice. Then I've got octal there, octal, decimal. Okay, so 2 unsigned string seconds value, base 8, which is octal, base 10, which is decimal, base 16, which is hexadecimal. So I'm just getting binary, octal, decimal, and hexadecimal. The little animation on Wikipedia's webpage just said binary and decimal. I've got octal and hex as well, just for fun. And then I'm displaying the date. Okay, and I'm applying that format. So that date time format there, I'm applying that to the current date time, which is our date time object here, represented by the seconds value times 1,000. Okay, so I'm just formatting the date and getting seconds value converted to binary, octal, decimal, and hexadecimal. Pretty simple stuff. So every time this method fires off, it's going to run all this code, and at the end it's going to add 1 onto seconds. Okay, so pretty simple stuff. And then down here we've got a main, I've got seconds value equal to integer.max value, so that's a maximum value an integer can contain in Java. And I'm taking 5 off it. Okay, because I want to step back 5 seconds before crunch time. Don't forget sec value is the number of seconds. So I'm getting the maximum value a second that integer can contain, and I'm taking 5 off it. So we're stepping back 5 seconds before crunch time. And then I'm starting the timer, seconds timer.start. This creates the timer, but it doesn't start it. So I'm starting it down here. And then this is a little trick here when you're running your code to keep the window open, the console window open and the application running. Just open a little scanner object and read in the next line. So the window stays there waiting for input. Okay, it's getting a bit loud with the rain, but anyway, it's nice and cool. It's finally cooling down. I should be taking a quad bike out tomorrow, see what all the rain's been doing. Righto, so let's run this and see how we go. And there's the code running. And when it gets down here a bit, I'll cancel it and then we'll step back through. Okay, so I've killed it there, that's why the error came up. So there it is, all ones, less 5 seconds. I took 5 seconds off it. And there's the octal, the decimal, the hexadecimal, and the date. So 19th of January 2038. Looking good. And then I add 1 second on. So there's a 1 there, went from 0 to 1. 7.2 went to 7.3, and so on. And it's 14.03, it was 14.02. Then we went to 14.04, 14.05, still 2038, everything's looking good. 2038, 14.06, everything's looking good. 14.07, and then bam. All our ones flipped to zeros, so we wrapped around our number, and the octal's gone to represent the new value, and so on. So and our time is now 14th of December 1901. So and 14th of December, so we started at 52, 53, 54, we just keep counting up from 1901. So that's the year 2038 problem. Okay, we can actually make it a little bit nicer than that. Let's convert this into a GUI. We'll set up a nice little GUI. So we've got a little GUI there. I'll just back up my works so far. So I'll call that version 3. Okay. Now let's convert this class into a GUI, and I'll show you how easy it is to make something a GUI. So we're going to make a Java desktop app, so it extends JFrame. Okay. Our main down here is going to create an object of this type. Don't need to worry about this anymore. We can chop that. Actually, I'll comment it out. So create an instance of our app.set size to 500 wide by 300 high. Let's just try that, see how we go. App.set visible to true. App.set default close operation. JFrame. Okay, that's pretty well all we need. We need a constructor. Public followed by the name of the class. No types. And what we might do is move this up into our constructor. Move that up there. We'll now make that an instance method. So it's just a instance method. We'll now make that just a normal timer without static. Just make that a normal integer without having a static in front. Doesn't really matter. But so what do we need? We need a bunch of labels basically, and a button to jump back, jump back 5 seconds. Okay, J button, jump back button equals new J button jump to 5 seconds prior. Okay, whatever, doesn't really matter what the name's in that, what it's got as a description. Then we need some labels. Label, oops, label, binary label, equals new J label, octal, decimal, hex, or hexadecimal, whatever you want to write, doesn't really matter. It's just a little simple app. That's probably all we need for now. So we've got a button there. So let's now, instead of printing out to the console screen, let's now update the labels. So it'll be label.setText. SetText, 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 SetText. We also want the date and time as well. Date, time label. Date, time label. Hex label. Hex, so we've got the hex one being updated for the hex. The decimal being updated for the decimal. Everything's lining up. The octal lining up for the octal. And the binary. And we don't need the print line anymore. Nothing's going to the console screen anymore. So our constructor needs to add these labels to our user interface. So what we might do is make our user interface a JFrame's a border layout by default, but I just like specifying it just so it's really clear what I'm doing. So we'll have a J panel, and it will be the outputs panel. Actually, let's just make it all one big grid panel. Grid panel equals new J panel, new grid layout. And we want 1, 2, 3, 4, 5 rows plus a button row, so 6 rows and 1 column. Don't worry about space in between it. Doesn't have to be pretty. It's just going to be very industrial, which is what I specialise in. Binary label. Whoops, binary label. I want to do that. Octal label, decimal label. Oops. Hex label, date label, and our button, jump back button. Okay. Then we set up our seconds value to a starting value and kick off our timer. And our timer calls the good old date time display method, which calculates the time and updates our labels. So we just need to activate our jump back button now. Let's compile and test, see how that looks. Ooh, new border layout. Okay, so import for border layout, import java.awt.star, and we're doing some button clicking stuff soon, so we'll bring in the events as well so that we can have clickable buttons. That's all we need. And there's no real disadvantage to bringing in all of a package. That's quite okay. Java doesn't mind. The compiled code is exactly the same. Java's an optimizing compiler, so it trims out all the fat. So there are no worries there. I tend to put the full things in now, but if I'm just writing code just to throw it away like this is, star's fine. Okay, so now we've got border layout. Border layout's in. And what we need to do is add our grid panel to the user interface. So let's just add grid panel. So we're adding it to the user interface. The user interface is a border layout, so by default it's being added to the center region, which is the big region in the center. But if you want to make it really clear, you can just go border layout dot center. That's okay as well, but you can leave that out and it automatically defaults to the center. Okay, let's run that and see how we look. Okay, so there's a user interface. 2038. 1901. Nice, that's working. So I might add a bit of a space in here to space those out. What do you think? Good idea. Space those out from the boundary a bit. And we're going to activate our button, so we'll do that as well. Okay, let's space them out a bit. We're just going to do cheap and dirty. It's only a throwaway app. It's only for fun. Righto, so just put a space in there before the set texts. Okay, we're in the set text. So what we're going to do is activate our jump back button, and we'll do that before we kick off the timer. Jump back button dot add action listener, and it's event, and I'll run the jump back method. Doesn't exist yet, but let's create it. Jump back. It's a private method. And the code we want is just this code here. We want to set the integer, set the seconds value to the maximum and take 5 seconds off. So it's just that code there. Control C, Control V to paste it. While we're making our methods private, this one should be private as well. Keep your data private and keep your methods private unless there's a very good reason for it to be public. So these should be really private. You can even make your GUI components private, doesn't matter. It means nothing outside the class can access them or change them or corrupt them or mess with them, which is nice little security to have. Okay, jump back. So jump back's actually running the same code. So we've got the same code in 2 places, and I don't like that. That's a bad thing. So what we'll do up here, we'll just call jump back. There we go. So before the application appears on screen, we'll jump back, and then whenever they click the button, we'll jump back as well, and this code here will run. That should be it. Control 1, Control 2. There's the app running. 2038. It's counting down the seconds. Woo! Or counting up the seconds. 1901. Let's jump back again. 2038. So I'll have about 5 or so seconds before it goes down to 1900. There it goes, 1900. So that's working great. We've basically written the same sort of app that was in the Wikipedia page, animated GIF, and what it took. It takes minutes, really, you know. So that's basically all I wanted to show you. Just create a little, our own version of that little app that's displaying the Y2038 problem. So just to recap, we created a seconds value. This is really the guts of it, the seconds value as an integer. And then we use that to construct a date, and a date takes a long, so we're converting the seconds value to a long and multiplying by 1,000 to get the milliseconds since the 1st of January 1970. And then we're just displaying it to the screen. And we're updating our seconds value. So not saying current date equals current date plus 1. We're saying seconds value equals seconds value plus 1 every time this method runs. If we added a second to the date, it would never have an error because, like I said earlier, the Java dates are good through till another 292 million years or so, give or take. Okay, that's basically it for this app. Just a nice, simple little GUI app. Now, I will say one thing. When you're learning to program, or even when you're an experienced programmer, or even when you're a programmer with decades of experience, it's a good idea to always keep exploring. That's the key to being a good programmer. Just keep exploring. I see TV ads or movies or documentaries, and I'm always thinking of ideas and of things to do, things to explore. I'm thinking of new assignment ideas. I'm thinking of new exam question ideas. I'm thinking of new fun little projects that I can do and maybe even do a video on. But I do so many things. I've got about probably over 60 projects on the go at once. Most of them will never see the light of day. They're just fun little projects of things I like doing. But I'm starting to do more and more of these sort of videos to hopefully encourage other people to do what I do, and that's enjoy computer programming. So anyway, hope that video was useful. Hope you got something out of it. Have a nice day. Thanks for watching.